Bismillahirrahmanirrahim. In this video, we'll try to clarify some doubts regarding earthing and grounding of electrical systems. So first of all, the object of the grounding of any electrical system is primarily for safety reasons. So it could be safety of the person or safety of the equipment. Now, two terms are used and there's a lot of confusion about it. So first of all, earthing or grounding is to connect specific part of an electrical power system or equipment with the ground. So like this equipment has been connected with the ground, or it could be a bigger system that is connected with the ground. Okay, now in UK system, this phenomena here that we described is called earthing. And in American system, they call it grounding because of the reason you have learned from here, obvious reasons, but they are same, no difference. And for more details, you can refer to Wikipedia. Okay, now let me explain a little bit on the transformer side. You know, the transformer in the domestic supply in Pakistan especially, the input is 1100 kVA, 11 kVA, and the output is 220 volt. Now, these are three wires, input side, three wires, and this is the top of the transformer. So they are connected in the bigger terminals here, and they are blue, yellow, and red. So three wires is the input, but the output is four wire. And how do we get four wire? Is that from delta, this side is star connection. So the neutral point is another wire. These three are the live wires or the phase wires, and this is the neutral point. So you can see here the three smaller ones for 220, and this white one is for the neutral wire or the ground wire. Now at the transformer terminal, you can see this wire going down and going underneath. It has been dug underneath. So this is the neutral point is also connected to the ground. So remember that the neutral is ground at the transformer terminal. And this whole system is called system grounding. And now we'll talk about the equipment grounding. Now this was system grounding. Equipment grounding is actually a pit is dug in the house, and from there we take connection and connect to all apparatus, all equipment that we have, like a motor, refrigerator, and freezer, and also your distribution box. So they are all connected to this ground. So this is called equipment grounding. And now actually, if you see the phase supply and the neutral from the transformer is connected to the phases or phase connection in the house, and this terminal is called now the neutral. So neutral in one phase, neutral in other phase, neutral in third phase. This is how this system works or the supply works. But if you see, this is connected to the body of the all devices. So this is also ground, this is also ground, but they are not same. They are at two different places, and through underneath, through the ground, it is connected, but there may be some difference in the potential. So we'll see that. Okay, now why we need to ground our equipment? That is the most important question. So let's see this single phase diagram. Phase coming, equipment is connected, maybe fridge, and it is returning through the neutral path. Now, if this body of the refrigerator is shorted, somehow this wire gets short circuited or touches the body, then what will happen? So this body will energize, this will have the phase voltage in it, and just like this fridge will have body will have phase voltage. And the moment someone touches the body, what will happen? The person has about 300 ohms of resistance. So the current through this will overcome 300 ohms of resistance and go to the ground through the body of the person, and he might get a big shock or he might die as well. So this is very, very dangerous. Now, how to avoid this? What we do is that we connect the body to the ground, as we had seen that a pit is dug, and through that all the bodies, all equipment bodies like the refrigerator or the washing machine or motors, their bodies are connected through this. And this only has a resistance of 1 ohm. It is desirable to have a resistance of only 1 ohm. So the current will now not go through this 300 ohms, rather it will go through the shortest path of 1 ohm, and the person touching will be safe. Now, unfortunately, in our country, the earth point in the domestic wiring is not non-existent. All that has been shown here, but it actually does not exist. If you look around your house, there is no point dug in the house for the earth point. So, for the safety, we should dig this type of a pit and connect all our equipments with this or the body of the equipment. Now, if this cannot be done because of any other reason, the simplest choice should be to connect metal pipe to all the ground points in the house. Okay. Now, if you have earthing system, how to perform test? Now, the best method is that you should have a earth testing meter, and this is an elaborate arrangement. We'll not go into this, but I'll show you a simple method which has been explained by WikiHow, and that is checking the earthing with a multimeter. So the first thing you do that between neutral and live, we connect the two probes of the meter, and let's say the reading is 230 volt. The next step is that we connect the probe between this earth and live. And let's say the voltage reading is now 231 volt. And the third step is that we connect the two probes between earth and neutral, and the voltage, let's say, is 0.5 volt. So the step that we should follow is step 2 minus step 1, that is 230, 1 minus 230, plus step 3 is 0.5, and it is 1.5 in this case. Ideally, it should be less than 2 volts if your earthing system is functioning properly. So I hope this gives you an idea about the whole scenario. Why we are getting 0.25 volt here? Because although this neutral is earth, it is earth at the terminal where the transformer is present, and that may be far away from the earth of our house, and there will be potential different, or there will be a slight difference in the earthing capacity of the two. So let me know through your feedback if you like this video. Thank you.